Hi everyone, in this video I'm going to walk you through the course Microservice API Rebuild. This is a custom backend solution developed using vanilla PHP and MySQL, no heavy framework attached. It is designed to handle everything related to academic management. We'll show you how it handles RESTful routing to create, read, and update courses. And check out the logic we wrote to manage dynamic schedule for different user roles like students and instructors. So let's dive into the code.
This section defines the core configuration of the horse microservice API. It declares constant for the database host, username, password, and database name, which are required to establish connection to the MySQL database. Centralizing these values makes the system easier to maintain and update. The base URI/API/v1 is also defined to standardize all API endpoints under a version path, which helps in managing future updates without breaking existing clients.
This part sets the HTTP response headers for the API. It allows requests from any origin to support cross-origin communication and specify that all responses will be returned in JSON format. The code also handles flight options requests, which are automatically sent by browsers before certain API calls. By declaring allowed HTTP methods and headers, this section prevents CRS-related issues and ensures smooth communication between the front end and back end.
This section establishes a connection to the MySQL database using the defined configuration constants. It checks whether the connection was successful, and if not, the API responds with an HTTP 500 status code and a JSON error message. Execution is immediately stopped to prevent further processing. This approach ensures that the API does not operate when the database is unavailable, improving system scalability and reliability.
Request method. URI requesting and root instruction. This file receives the HTTP request method and files the request. URI determine the target endpoint. The URI is broken into segments to extract the resources, name optional ID, and the sub-resources. The code especially look for IPv1 part processes everything that comes after it. This allows a single entry point file to dynamically handle multiple endpoints and request types.
Main routing. This section serves as the central decision-making logic of the API. It checks whether the request resources scores and then determines the correct action based on the request method and URL structure. The router direct request to function for retrieving courses, creating courses, updating courses, and managing user schedules. If an unsupported method or invalid endpoints is accessed, appropriate HTTP error responses are returned.
Retrieving courses or GET requests. This part handles retrieving course data from the database. The API supports fetching all courses or filtering them by department using query parameters. It also allows retrieving a single course by its unique ID. Prepared statements are used to prevent SQL injection, and results are returned as JSON arrays or objects. If a requested course does not exist, the API returns a 404 error, ensuring clear and accurate responses.
Creating and updating course. This section manages the creation and updating of course records for course creation. The API reads and validates JSON input data before inserting it into the database. For update, the API dynamically builds the SQL query so that only the provide fields are modified. This ensure flexibility the data integrity. Proper HTTP status codes are returned to indicate success or failure for the operation.
This part retrieves a user's schedule by first identifying the user's role from the user's table. Based on the role, the API dynamically selects the appropriate schedule table. It then joins schedule data with course information to provide complete details such as course name, units, and schedule time. This role-based approach allows one endpoint to support multiple users types efficiently. This section handles the creation of new schedule entries for users, validates the required input data, determines the user's role, and inserts the schedule into the correct role-based schedule table. The API supports optional schedule dates and returns a successful response upon successful insertion. This ensures accurate schedule management while maintaining a clean and scalable API design.
Get request or retrieving data. These endpoints are using to fetch information from the database without modifying it. Get all courses. The method that we are used is get. So the endpoint is core service API v1 courses. Description retrieves a complete list of all available courses in the system. Example, HTTP localhost course service API v1 courses.
So why we use post instead of put in method of updating data from database? Well, because Infinity 3 has firewall security that often blocks requests like put and delete, and they're considered unsafe on their free tier. So that's why.
Put request updating data. This endpoint is used to modify existing record, update course details, method endpoint course service API B1 courses ID, description, update specific details of an existing course, such as the number of unit or the department name, identified by its course ID. Body payload requires a JSON object with the file fields to update. Unit 6 Department Advanced Mathematics.
The next example is Courses 101 schedules.
Post requests, creating data. These endpoints are used to create new records in the database. Create user schedule. Method posts. Endpoints. Course service. If API B1 course user ID and schedule. Description. Assign a specific course to user, student, or teacher. At a specific time and day, it creates a new entry in the schedule table. Body payload requires a JSON object containing course, course ID, schedule time, and schedule day. Example, for student 101 adds a class to their schedule. For teachers, 201 adds a teaching slot to their schedule.